Hey guys, so in this video we'll be doing some questions that are based on Fourier series or on Fourier approximation. So we'll be finding Fourier series or Fourier approximation of a function. So to find Fourier approximation of a function, so to find the Fourier approximation of a function, we have three constants that we have to determine, or three coefficients for the Fourier approximation. So the first constant that we're going to determine, or the first coefficient, will be a of 0, which is given by 2 over p, and then integral from integral of f of x dx. And then the second one will be an, and that one, which is equal to 2 divided by p integral f of x cosine of 2 pi nx divided by period dx. And then the third constant will be bn, which is 2 over period integral of f of x sine 2 pi nx all over p, which is the period of the function. So we can see that the only difference between an and the bx is that the other one uses cosine and the other coefficient uses a sine. So with the a in some books, with the a of 0, this ao will be given as 1 over p and then integral f of x dx. But anyways, at the end of the day, the answer will be fine depending on how the Fourier approximation formula is written. So after finding these coefficients, we need to find now the Fourier approximation, and then which is given by a function f of x is equal to ao divided by 2 plus the sum from n is equal to 1 to infinite over of an, and then we have cosine of 2 pi nx divided by the period, and then we have plus bn, and then sine of 2 pi nx divided by the period, and then that's what we will have. So now you can see that the value of a, if it's given as 2 over p there, will be equal to, in the Fourier approximation, will be having a over 2, ao over 2. Then if it's given 1 over p, and then we have the integral of f of x and then dx, then it will just be given as ao. It's not gonna be divided, so actually it will give you the same thing at the end of the day. So yes, that's how it is. So now let's try to tackle some question. So a question that I have here says that find the Fourier approximation of the following function. So now the function that we're given, I'm just gonna check the function quickly. We're given this function here. Yes, so this is the function that we are given, and this says f of x is equal to 3, 0. It's a step function from 0 is greater than or equal to x less than pi, and then we have 0 from pi greater than equal to x less than 2 pi. So now that is the function that we are given, and we are given that if f of x is equal to f of x plus 2 pi, so that shows us the what, the period of the function. So now, first things first, we need to find the first coefficient, and we set down. So now we said the first coefficient now will be AO, which is 2 over P integral of f of x multiplied by dx. So that's going to be 2 divided by period. You can see now that our function is defined there from 2 pi. It is defined from 0 to pi and from pi to 2 pi. So for the sake of simplicity, since we know that the one that is 0 below the function, the other part of the function that is defined from pi to 2 pi is 0, so I'll just not consider that. I'll just start from, obviously, the period. Now we have 2 pi and then integral, as we are given there, if the function f of x is equal to f of x plus 2 pi. So now I'm just gonna move from 0 to pi, because our function there is 3 f of x and then dx, because I know the other part is going to give me a 0. So now I'm gonna have 1 over pi, and then I'm gonna integrate there. I'm gonna get 3x and then integral from 0 to pi, and then this should give us 1 over pi into, if we take out 3, we'll be having 3, and then we have pi minus 0, and then that should give us a 3. So that's the first coefficient there of the Fourier approximation. So now secondly, we find an, which is the second coefficient, which will be 2 over p integral of f of x, and then we have cosine of 2 pi nx divided by the period multiplied by d of x. So that's going to be 2 divided by our period, which is 2 pi, and then we integrate from 0 to pi. Just say from 0 to pi, because we said our function is defined is 3 from 0 to pi and 0 from pi to 2 pi. So I'm going to ignore that once again. So I'm going to have 3, and then I'm having cosine. So if I substitute in place of period a 2 pi will cancel the 2 pi there, and I'm just going to be left now with nx and then multiply by the dx. So now what I can do is that I can actually say 1 over pi, and then I integrate that, and if I take 3 out, I'm gonna have 3 over pi, because the 2 will cancel the 2, and then if I integrate, the cosine will be sine of nx divided by n, which is the derivative of the inner function from 0 to pi, and then that's gonna give me 3 over n pi into sine of nx from 0 to pi. So he said if you put your calculator in radians there and you substitute any number, for example sine 1 multiplied by, that should be 1 multiplied by pi, that should be pi instead of x. Or let's first start by substituting our limits. So that's gonna be 3 over n pi, and then into, we're saying now sine of n. In place of x we put pi minus sine of 0, which is just 0. So I have 3 over n pi into, now we said that we're gonna have sine of n pi because the other side will be 0. We said for sine of n pi, if you program your calculator, you put into radians, and then you say sine, for example, of 1 over pi, will get 0. Sine of 100 pi, you get 0. So everything that you substitute there, you get 0. That means that function will just be 0, as we said in the first videos. So that's an. And then now we'll move to the second coefficient, which is bn, and we say bn is 2 over p, the integral of f of x now is going to be sine of 2 pi nx divided by the period multiplied by dx. Therefore we have bn, which is 2 over 2 pi, said our function is 3, and then that's defined from 0 to pi. Yes, and then we have multiply by 3, sorry, then we have 3 sine of, when we substitute our 2 pi cancels 2 pi, and we are left with nx dx. So we're going to have bn, which is equal to 1 over pi. In fact, taking the 3 outside, and then 2 cancels 2, we get 3 over pi. Now we have integral from 0 to pi of sine of nx and then dx. So our bn should be 3 over pi, and then integrating sine, we will have cosine and negative cosine of nx divided by n, and then that's integrated from 0 to pi. So now we have our bn, which we can take negative 3 over pi there, and then we are left with cosine from 0 to pi. So that means we'll be having cosine of n pi minus cosine of 0, and then we say bn now is equal to negative 3 over pi into cosine of n pi minus 1. So that is what we have there. So again, when you substitute values there, as we did in the first videos, we'll notice that our bn now will be negative 3 over pi, and then we get the values now of negative 2 and 0, and then we get negative 2 when n is in an odd number, and then we get when n is even number is 0. So that is our function there. So now we go again and find the last coefficient. Actually we are done, is AO, AN and BN. So now we're writing the formula for approximation f of x. Now f of x will be AO divided by 2 plus, now the from 0, the sum from 0, n is equal to 1, sorry, and then to infinity there, and then we have what? We have A of AN, and then we have cosine of 2 pi nx divided by the period, and then after that we say plus, now bn we say sine of 2 pi nx divided by the period. So after that, what we do, we say now f of x will be equal to AO. Our AO we said is 3 over 2 plus, because we said our AO is 3, and then plus now the sum from n is equal to 1 to infinity. So definitely, since we said now we got our A, the first coefficient AN, to be 0, in fact the second one, so that means we're gonna have 0 there. So we don't have that. We'll be left with bn sine of, and we said that now the period is 2 pi. When we substitute there 2 pi, the 2 pi cancels 2 pi, and then we'll be having, now we'll be left with nx, and then that's what we have. So now we say now f of x now is equal to 3 over 2 plus, now we have what we consider our bn now. Then we set our bn is, if we multiply there our bn, we can see that we're gonna get what? We're gonna get a 6 over pi, and then that happens when actually we should have n here also, we should have n here, we should have n there, so that should be 6 over n pi. That happens when n is equal to n odd. So the one for 0 when n is equal to even, we can ignore it because it's 0. Otherwise you can show it if the question requires to do so, but at the end of the day those terms will just disappear. So that means we have 6 over n pi when n is equal to odd. Our bn is 6 over n pi when n is equal to odd numbers. So what we do now, we're going to say now we are having this b1 and then sine odd number. The first one is 1x and then plus b2, and then still we have sine, and then we have 3, which is the second odd number, and then again we have b3, and then we have sine, and then we have 5x plus, and then etc. And then now we're going to have f of x, which is equal to 3 divided by 2 plus, in place of b1 now we substitute there. We substitute our even numbers. Once again we substitute 1, we're substituting 3, we're substituting 5. So when we substitute those there, when substitute 1, we'll get 6 over a pi and then sine of x, and then plus the second one we're substituting 3, we get 6 over 3 pi and then the sine of 3x. The third one we substitute 5, we get 6 over 5 pi and then the sine of 5x and then plus etc. So now we're going to have f of x, which is going to be 3 divided by 2 plus. Now we can take out common factor to simplify it, which is 6 over pi appearing in all the terms, and then we'll be left with 6 with sine x plus that's gonna be 1 over 3 sine of 3x, and then plus 1 over 5 sine of 5x plus etc. So that is how we can find now. That is our final answer for our Fourier series or our Fourier approximation. So that's how it is done. So we have answered the question. So now the second example, we're given that now our f of x is equal to, so now we have 0, we have 3, we have 0, and we said from pi greater than less than x, and then that's gonna be negative pi over 2, and then we have from negative pi over 2 less than or equal to x less than pi over 2, and then we have pi over 2 less than or equal to x less than pi. So those are our limits there. So they are saying now if f of x is equal to f of x plus 2 pi. So our period p will be 2 pi. So first of all, we find a of 0, which will be the 2 over the period integral of f of x dx. That's gonna be 2 divided by 2 pi integral. Now again, once more, I'm gonna ignore the first part and the third part of the function because they are 0. But if the question requires you to show, you can show them. But at the end of the day, those terms will disappear. So that means now we'll just be left with what? With a function which is 3. And then this function is defined from negative pi over 2 to pi over 2. And then dx. So that's going to be now 3 over pi, because the 2 will cancel 2, taking the pi to the other side. Then we are left with the dx which is now going to be x from integral of negative pi over 2 to pi over 2. So that should be a of 0. That should be, now substitute our limit 3 over pi, and then we substitute pi over 2, then we minus, which will be plus pi over 2, and then our a of 0 will be 3 over pi multiplied by pi over 2 plus pi over 2 is pi, and then our a of 0 should be 3. So that's how we can find our first constant for this question. So we get 3, and then now next we find our NaN, which is the second coefficient, and then that's 2 over pi integral of f of x set cosine of 2 pi nx divided by the period multiplied by dx, and we say now of an, which is 2 pi divided by 2 pi. Sorry, that should be 2 divided by 2 pi. Integral, we said our function is 3 from our piecewise or from our step function. And then that's divided from negative pi over 2 to pi over 2. Then we have cosine. When we substitute period there, we're going to be left with nx and then multiply by dx. An should be that, cancels that, you're left with 3 over pi integral from negative pi, or we can already integrate that. Integral of cosine will be sine of nx divided by n, and then that's evaluated from negative pi over 2 to pi over 2. And then we have an, which is now 3 over n pi, and then we have now, we can substitute our limit. It's going to be sine n multiplied by pi over 2 minus sine of n multiplied by pi over 2, but that should be negative. If we take that negative outside, that will cause a positive there. So I have an, which is now 3 over n pi into sine n times pi over 2 plus sine n times pi over 2, will be getting sine 2 sine of n pi over 2, and then an now should be equal to 6 over n pi of cos sine of n pi over 2. So if that was just sine n pi, it will be 0, but now we have sine n multiplied by pi over 2. Now that's not gonna be 0. That means now our an will be equal to 6 over n pi, and then what's giving us now, what we are getting now, we are getting some values, and then those values, the first one will get 0, will get 1, will get negative 1, and then we'll notice that we get those values when n is equal to 1, when n is equal to 1, and then when n is 5, when n is 9, etc. And then again here when n is 2, 4, 6, etc. And then here when n is equal to 3, 7, and then when it is 11, etc. So negative 1, so the function alternates from negative 1 to 1 when it alternates with even numbers from the next even number to another. So now after this we need bn, and then we said our bn will be 2 over period integral of f of x sine of 2 pi nx divided by the period multiplied by dx. So you see now bn is equal to 2 over 2 pi integral of 3 sine of 2 pi. If we substitute period 2 pi there, we'll be left with nx and then dx. So bn should be equal to 1 over pi, and then we can take out 3 to get 3 over pi sine of nx and then dx. So our bn should be 3 over pi multiplied by integral of that will be negative cosine of nx divided by n evaluated from, that should be evaluated from negative pi over 2 to pi over 2. Should have substituted those there and there and there and there. So that means now we're going to have bn, which is equal to 3 over n pi. So substituting our limits, let's take out the negative sign also. We get cosine of n multiplied by pi over 2 minus cosine of n multiplied by pi over 2. So our bn will just be 0 because that will cancel that. So that means we are only left with our, so we said that our a, we got 3, a of 0, that was 3, and an we got what? So for an we got 3 values, but the values that are effective there is 1 and negative 1. And we can remember, we can write that as an is equal to, so we can say 6 over n pi. And then again we can say negative 6 over n pi. I'm just going to ignore the 0, 1 because it's actually 0. So that means now we have 6 over n pi, negative 6 over n pi, and then that should be 1, 5, and 9 when n is equal to 1, 5, and 9. And then when n is equal to here, I believe it should be 3, 7, and 11. Let's double check. 3, 7, and 11. It's like that. And then now, what we're gonna do, we're writing the formula for Fourier approximation. So that is going to be AO divided by 2 and then plus the summation from n is equal to 1 to infinite, and then we have the bn, we have an, and then we set cosine of 2 pi n x divided by the period, and then we say plus bn sine of 2 pi nx divided by the period. First of all, I'm going to simplify that to f of x is equal to, in place of AO I put 3, and then that becomes 3 over 2, n is equal to 1 to infinite, and then I have now an, and then I have an, and then cosine, when I substitute the period there, gonna be left with nx, and then that term will just be 0 because our b, we found it to be 0. So now I'm gonna have f of x, which is equal to 3 over 2 plus, now we're going to substitute a1 cosine of, now we have what for an, we have 1, that means we're gonna have 1x, and then plus a2 cosine, the following one is 3, gonna have 3x, and then we say plus again a3, and then cosine, the following one is what is 5, that's gonna be 5x, then plus etc etc. So we're gonna have f of x now is equal to 3 over 2 plus, now a1 we substitute into the function, since we have alternating values there. In place of an we have negative 6 over n pi and positive 6 over n pi. So we're gonna substitute first 1 there, gonna substitute that value 1, and then what we get, we're going to get 6 over pi, that means we're gonna get 6 over pi cosine of x, we say plus, now we're coming to where, we're coming to 3, When you substitute 3 there, we're gonna get what? We're gonna get negative 6 over 3 pi. And then that's cosine of 3x. And then we say plus, the following one is 5. So now we're gonna get what? 6 over, and then that function is positive there. So that means it's gonna be positive 6 over 5 pi, and then cosine of 5x plus etc etc. So you're gonna have f of x, which is 3 over 2, and then plus 6 over pi, and then now we have into cosine of x, and then plus, in fact, minus. When we remove the 6 over pi, we get 1 over 3 cosine 3x, and then plus, when we remove 6 over pi, we get 1 over 5 cosine of 5x, and then plus etc etc. So that's our Fourier series, or our Fourier approximation. That is how we can find or solve those questions. Thank you.